Yes, you can connect the spa to the office outbuilding, but there are several crucial electrical requirements to consider for a safe and code-compliant installation. Firstly, the spa must be powered by a dedicated GFCI protected circuit. Secondly, the circuit breaker must be sized appropriately for the spa's load, which is typically between 30 and 50 amps. Thirdly, the wiring must meet specific requirements to ensure safety and prevent electrical hazards. Use rigid metal conduit, or RMC, for the underground run to protect the wiring from physical damage. Use type UF cable for both the underground and overhead portions of the wiring. UF cable is specifically designed for outdoor use and direct burial, providing resistance to moisture and physical damage. The conduit and cable must be properly grounded to ensure electrical safety and prevent shocks. Install a GFCI outlet outside the outbuilding to provide ground fault protection for the spa. Run the spa's extension cord from the spa to the outlet, ensuring that the extension cord is not damaged and is rated for outdoor use. The circuit breaker for the spa and office must be dedicated, meaning it should not be used to power other devices or appliances. This prevents overloading the circuit and ensures the spa receives the necessary power. Additional considerations include consulting with a qualified electrician to ensure that the installation meets all applicable electrical codes and safety regulations. The spa should be properly bonded to the electrical system and grounding rods to provide an additional layer of safety. Consider installing a drain or overflow system to prevent water accumulation around the spa, which can create a safety hazard. It's important to emphasize the necessity of a dedicated GFCI protected circuit. This is not just a recommendation, it is a critical safety requirement. A GFCI, or ground fault circuit interrupter, is designed to detect ground faults, which occur when electricity flows through an unintended path, such as through a person. When a ground fault is detected, the GFCI quickly shuts off the power to the circuit, preventing serious injury or death. The National Electrical Code, or NEC, mandates GFCI protection for outlets located near water, such as those serving spas and hot tubs. Neglecting this requirement can lead to severe electrical shock hazards. The appropriate sizing of the circuit breaker is also paramount. A circuit breaker protects the electrical system from overloads, which can occur when too much current flows through a circuit. If the circuit breaker is too small, it will trip frequently, interrupting the spa's operation. If the circuit breaker is too large, it will not provide adequate protection, and an overload could cause the wiring to overheat and potentially start a fire. The spa's manufacturer should provide information on the required circuit breaker size. If this information is not available, consult with a qualified electrician to determine the appropriate size. The use of rigid metal conduit, or RMC, for the underground run is another important safety measure. RMC is a type of metal conduit that is designed to protect wiring from physical damage. It is particularly important to use RMC for underground runs, as the wiring can be exposed to moisture, corrosion, and physical damage from digging or other activities. RMC is also required in certain locations, such as where the wiring is exposed to physical damage or where it passes through a hazardous location. UF cable, which stands for underground feeder cable, is specifically designed for direct burial applications. It is constructed with a moisture-resistant jacket that protects the conductors from water damage. It is also sunlight-resistant, preventing degradation from exposure to ultraviolet rays. While other types of cable, such as NM cable or non-metallic sheath cable, are permitted for indoor use, they are not suitable for direct burial or outdoor applications. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker to trip and clear the fault. This prevents the metal parts of the spa and electrical system from becoming energized, which could pose a shock hazard. The grounding system typically consists of a grounding electrode, such as a ground rod, which is connected to the electrical panel. The grounding conductor then runs from the electrical panel to the spa, bonding the metal parts of the spa to the grounding system. The use of a dedicated circuit breaker is also crucial for safe operation. Sharing a circuit with other devices or appliances can overload the circuit, causing the circuit breaker to trip frequently. This can also lead to voltage drops, which can damage the spa's components. A dedicated circuit ensures that the spa receives the necessary power without being affected by other electrical loads. Consulting with a qualified electrician is always recommended, especially when dealing with electrical installations. An electrician can assess the specific conditions of the installation, ensure that the wiring meets all applicable codes, and perform the work safely and correctly. Electrical codes are complex and can vary depending on the location. An electrician is familiar with these codes and can ensure that the installation complies with all requirements. Bonding the spa to the electrical system and grounding rods is an additional safety measure that helps to equalize the voltage potential between the spa and the surrounding earth. This reduces the risk of electric shock if a fault occurs. A bonding conductor is run from the spa to the grounding electrode system, providing a low impedance path for fault current to flow back to the source. Installing a drain or overflow system can help to prevent water accumulation around the spa. Water accumulation can create a slip hazard and can also increase the risk of electric shock. A drain or overflow system can help to divert water away from the spa, keeping the area dry and safe. When running the spa's extension cord, ensure that it is not damaged and is rated for outdoor use. Outdoor extension cords are designed to withstand the elements and are typically constructed with a heavier gauge wire than indoor extension cords. Damaged extension cords can pose a shock hazard and should be replaced immediately. In addition to these electrical requirements, there are also several other safety considerations to keep in mind. Never use electrical appliances while in the spa. Avoid using the spa during thunderstorms. Inspect the spa regularly for any signs of damage or wear. Keep children away from the spa when it is not in use. Follow the manufacturer's instructions for the safe operation of the spa. When selecting a location for the spa, consider the following factors. Choose a level surface that can support the weight of the spa filled with water. Ensure that there is adequate drainage around the spa to prevent water accumulation. Locate the spa away from overhead power lines. Provide easy access to the spa for maintenance and cleaning. Consider the privacy of the location. In summary, connecting a 110-volt spa to an outbuilding requires careful attention to electrical requirements and safety considerations. By following these guidelines and consulting with a qualified electrician, you can ensure a safe and code-compliant installation. Remember, the use of a dedicated GFCI-protected circuit, appropriate wiring methods, proper grounding, and adherence to all applicable electrical codes are essential for preventing electrical hazards and ensuring the safety of yourself and others. Ignoring these requirements can have serious consequences, including electrical shock, fire, and even death. Take the time to do the job right and enjoy your spa safely and responsibly. Ensuring the circuit breaker is appropriately sized typically requires calculating the total load that the spa will draw. The spa's nameplate should list its electrical requirements, including the voltage, amperage, and wattage. Use these values to determine the appropriate circuit breaker size. For example, if the spa requires 20 amps at 110 volts, you would need a 20 amp circuit breaker. However, it's always a good idea to add a safety margin of 20% to the circuit breaker size. In this case, you would need a 25 amp circuit breaker. Also, when using UF cable for underground wiring, it's important to bury it at the proper depth. The NEC specifies the minimum burial depth for UF cable, which varies depending on the voltage and the location. For a 110 volt circuit, the minimum burial depth is typically 12 inches. However, it's always a good idea to check the local electrical codes to ensure that you are complying with all requirements. It is also important to protect the UF cable from physical damage where it exits the ground. This can be done by using a conduit riser, which is a section of rigid conduit that extends above the ground. The UF cable is then run through the conduit riser to protect it from damage. When installing the GFCI outlet, it's important to choose a location that is readily accessible and protected from the elements. The outlet should be installed in a weatherproof enclosure to prevent water from entering the outlet and causing a short circuit. The outlet should also be located at least 12 inches above the ground to prevent it from being submerged in water. When running the spa's extension cord, it's important to avoid creating a tripping hazard. The extension cord should be routed in a way that minimizes the risk of someone tripping over it. The extension cord should also be secured to prevent it from being pulled out of the outlet. It's also important to avoid using excessive extension cords. The longer the extension cord, the greater the voltage drop. Voltage drop can damage the spa's components and reduce its performance. If you need to use an extension cord, choose one that is as short as possible and is rated for outdoor use. Finally, it's important to regularly inspect the electrical system for any signs of damage or wear. Check the wiring for any cracks, cuts, or abrasions. Check the outlets for any loose connections or corrosion. Check the circuit breaker for any signs of overheating. If you find any problems, have them repaired immediately by a qualified electrician. Maintaining the electrical system in good condition will help to ensure the safe and reliable operation of the spa. Consider using a surge protector to protect the spa from power surges. Power surges can damage the spa's electronic components and reduce its lifespan. A surge protector will divert the excess voltage away from the spa, protecting it from damage. Also, be sure to clearly label the circuit breaker that serves the spa. This will make it easier to identify the correct circuit breaker in the event of an electrical problem. The label should indicate that the circuit breaker serves the spa and should also include the voltage and amperage of the circuit. This information will be helpful for anyone who needs to work in the electrical system in the future. Finally, remember that electricity can be dangerous. Always take precautions to protect yourself from electric shock. Never work on electrical equipment while it is energized. Always turn off the power at the circuit breaker before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Prioritizing safety and following these guidelines will contribute to a safe and code-compliant spa installation.